Nowadays, nano is so popular. We can always hear nano this and nano that in our lives. Nano is everywhere in our world, and thermal interface material is one of them. So, what is TIM, a thermal interface material? Thermal interface material is a material with high thermal conductivity and also can be conformed to the imperfect mating surfaces. It can be used to fill gaps between thermal transfer surfaces so that it can increase thermal transfer efficiency. Why is TIM important? Well, in our daily lives, we are dealing with a lot of electronic devices, like the ones in laptops, cars, cell phones, and something like we. And as the electronic devices are getting smaller and faster, the heat generated per unit area is increasing dramatically. Due to a survey, more than 50% of electronic failure is because of the temperature. So, a TIM is applied to ensure the optimum performance of electronic devices. It's applied between a chip and heatsink to help dissipate the heat generated from the chip. So this is a schematic showing the chip, sink, and where the TIM located. The red part is the chip, the black part is the sink, and in between there used to be air, and now it's replaced by our TIM. Okay, then what makes it an ideal TIM? In other words, what's the criteria to select a TIM? Well, at first, an ideal TIM must have a high thermal conductivity, and then it should be easily deformed by small contact pressures. And of course, there will be no deterioration over time and non-toxic. At last, it will be easy to apply and remove. Okay, now we know what's TIM, why it's important, and how to select it. Then you might wonder how to make TIM in reality. Well, let me show you. In our lab, we use epoxy and silver nanoparticles to make the TIM. At first, you have to mix the hardener and the resin of the epoxy to get a solution like this. And then we introduce the nanoparticles. It's a 20 nanometer silver nanoparticles. It's quite small, and the reason why we use the silver nanoparticles is because the bulk silver has a very high thermal conductivity. So we were wondering, when we introduce the nanoparticles into epoxy, can the thermal conductivity of the composite also be very high? Well, we'll see. And let's try it. This is what it looks like when we first pour the silver nanoparticles into the epoxy. And then we sonicate it. This is what we use in our lab. It's called a sonicator. And when we look closer to the suspension, we can see there is a hole dig into the suspension. And when a sonicator is working, there will be a lot of energy generating on the tip of the horn. And this energy can be used to help the dispersion of the silver nanoparticles into the epoxy. And I'll show you how it works. Okay, after 1 hour of sonication, we get a uniform dispersion of silver nanoparticles into epoxy, or it's a uniform suspension. The next step is to place the liquid tin onto the silicon wafer to make a sandwich tin. So you can consider the two silicon wafers to be the heat sink and the chip. In between there is our nano tin. If you look at the sandwich tin from a different angle, it will look like this. Next, we put the sample into the furnace to cure it. And after staying in the furnace for a certain time at a certain temperature, our final tin is ready. You see the shining part in the middle? Yes, that's our tin. A tin made of epoxy and silver nanoparticles. Compared to the pure epoxy, we observe a 150 increase in thermal conductivity for our tin. And it's really exciting, and that's why we make the tin.